So hello, good morning. So we have discussed in the previous classes about Newton's Raphson method to find the solution of an equation. Now today we are going to discuss the Python program to find the solution of the equation using Newton-Raphson method. So in Newton's Raphson method, so first of all we have to find an approximate solution of this equation. Now if x0 is an approximate root of this equation, x1 is equal to x0 minus f of x by f dash of x0. That will be a closer solution of this equation. So similarly from x1 we can find further improved root x2 such that x2 is equal to x1 minus f of x1 divided by f dash of x1. In general, the solution of the equation in Newton's Raphson method can be expressed as xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So this method is known as also known as Newton's iteration method. So these things we have discussed in the previous videos. Now let us see how can we write the algorithm of this particular program. First of all, we have to define the function f of x. Now also we have to define the derivative of this function f of x. So that is f of x and f dash of x. Both should be known. Initialize x is equal to 0. Assign and root. So we can assign a value to this what is called the root. Check the absolute value of root is greater than 0.0001. That means check whether this function, when the value of root is substituted in the function, if it is equal to 0. So sometimes we may not reach exact 0 values. That is why we are taking a value very close to the 0. If it is greater than this, we have to repeat that iterations. Otherwise we can take that as the solution if it is that much closer to the solution. If absolute value of f root is greater than this value, go to the next step. What we have to do? Assign value of root to x. The root value, we have given an approximate value to solution to this what is called the root, and the value of root is assigned to x. Then compute root is equal to, again compute a new root, that is x minus f of x divided by f dash of x. After computing this, go to step 5. Check whether that new root is greater than 0.001. If so, repeat these steps. And when this is equal to, is less than 0.0001, you can take that value of root as the solution. Print the value of root. So these things we have discussed in the previous classes. Now let us check how can we write this program. So import math. We have to define the function first. Define f of x. Return x squared minus 2. So simply we are finding the root of 2 here. X squared minus 2. Now find the derivative, define the derivative of this. Define f1 of x, derivative f dash instead of f dash of x, we are naming it as f1 of x. Return the derivative, in the derivative of 2x, 2 into x. Give a initial value of x is equal to 0, 0.0. So this is the approximate solution, we 2 ആയിട്ട് root 2. While absolute value of f root, the രണ്ട് ബ്രാക്കറ്റിൽ ഇടണം, f of root approximate solution നമ്മൾ എടുത്ത് root is equal to 2 ആണ് എടുത്തത്. ആ f ഈ ഫംഗ്ഷനിൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ അതിൻ്റെ വാല്യൂ ഗ്രേറ്റർ ദാൻ 0.0001 ആണെന്ന് ചെക്ക് ചെയ്യുക. അപ്പോൾ ഇവിടെ 2 കൂടെ കൊടുത്തു കഴിഞ്ഞാൽ നമുക്കറിയാം 2 squared minus 2, that is 4 minus 2, that is 2. It's much greater than this value 0.001. That is not the solution. ഇത് സൊല്യൂഷൻ അല്ലെങ്കിൽ ഇതിൻ്റെ അപ്രോക്സിമേറ്റ് വാല്യൂ ഇതിലേക്ക് കൊടുക്കുക, എക്സിലേക്ക് കൊടുക്കുക, x is equal to root. Now find a new root, that is root is equal to root minus f of x divided by f1 of x, that is f of x divided by f dash of x actually. Then repeat this process until f root is less than 0.001. അതായി കഴിയുമ്പോൾ എന്ത് ചെയ്യുക, പ്രിൻറ്റ് ദ വാല്യൂ ഓഫ് റൂട്ട്. അപ്പോൾ ഇതിൽ ഈ പ്രോഗ്രാം നമുക്ക് റൺ ചെയ്യാം. റൺ മോഡ്യൂൾ കൊടുക്കുക. സോ ദ സൊല്യൂഷൻ ഈസ് ദിസ്, root is equal to 1.414. Then you know that is the value of root 2. Okay, now we can change that function. So x cube minus 2, so the derivative also will be 2. X cube in the derivative then 3x squared to x squared. So you are getting cube root of 2 here. Save here now. You can run module. So the solution is 1.2599 etc. You can check whether this value of function is f. You can find the value of f root here. Let's get right, print f of x. Okay. Okay. അപ്പോൾ റൂട്ടിൻ്റെ വാല്യൂ 1.2599 കൊടുത്തു കഴിയുമ്പോൾ എഫ് ഓഫ് എക്സിൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ 2.48 ഇൻറ്റു 10 റേസ്ഡ് എക്സ്പോണൻഷ്യൽ -12 ആണ് വരുന്നത്. ദാറ്റ് ഈസ് വെരി ക്ലോസ് ടു ദ മച്ച് ക്ലോസ് ടു 0. So this is a solution of this particular equation. Okay, you can change, you can give any function here. So only one thing is that function should be differentiable, and you have to give the derivative of the function in this. Also you have to find substitute the derivative of the function here. Okay, bye.